Welcome to Section 3 of Chapter 12, which is a continuation of surface area. In Section 2, we did surface area of prisms and cylinders. Today, we're going to do surface area of pyramids and cones. So, we're going to calculate lateral and surface area, and then we're also going to work backwards. I'm going to give you the surface area, and you're going to calculate a missing side, radius, height, etc. Before we jump into calculating surface area, we have some vocabulary to talk about. First thing I want to talk about is, well, what's a pyramid? We've learned this before, but a pyramid is a polyhedron, just means a 3D solid, with one base. And also, the faces are all triangles. The lateral faces, that is. So you're going to notice we have two pyramids. In both, the base is a rectangle and the lateral faces are triangles. Now, the base doesn't have to be a rectangle, but they are in these two cases. The vertex is the point where all the triangles meet. So here would be one vertex, here would be the other vertex. And it's where those lateral faces, those lateral triangles all meet. In a regular pyramid, the base is a regular polygon. So a regular polygon meaning equilateral and equiangular. So on that second figure, the one marked regular pyramid, the base is a square. All the sides are congruent. And then last one, the slant height, is the height of a lateral face. Okay, so if you look at that second figure, there's two heights. There's the height in red. This is the height that comes from the vertex and is perpendicular to the base. The slant height, on the other hand, is the height of that triangle. So it's on a slant. It's not straight up and down. We're going to be using the slant height a lot today, but then volume is going to use the normal height. So you do need to know the difference between the two. So, surface area of a pyramid. Exactly the same as a prism, just add up all the faces. The areas of all the faces, that is. And just a note, the height of each triangle is the slant height. So that perpendicular height in red on the figure, we're not going to be using that today. We're going to be using the blue figure, or the blue height. So let's look at example number 1. Example 1 says, find the exact area of one lateral face. Okay. So we're not being asked for the surface area, we're not being asked for the lateral area, we're being asked for the area of one triangle, that's it. So like the area of this triangle, for example. That's what we're being asked for. So area is going to be 1/2 base times height. The base of each triangle is 16. The height is what we don't know. It's what we have to solve for. We're given a height of 15, but remember that this is the height of the pyramid. So it's the perpendicular height. It's not actually the height of the lateral faces. Because if you notice those lateral triangles, they're tilted. So 15 is not the height of those tilted triangles. Now, you're going to notice that the figure has drawn in this triangle for you. It's very faint, but it's drawn in. Now, we have 15 as one side. We're going to need this side, the slant height, because that slant height is going to be the height of the lateral faces of those triangles that are tilted. I'm going to mark that L, like they have. So slant height is normally with an L. Now, this side of the triangle, it's half of the base. Our base is 16, so that is going to be 8. So redrawing that triangle, I have 15, 8, and then the slant height L. So hopefully we can tell we should be using Pythagorean Theorem. I have 15 squared add 8 squared equals L squared. 15 squared add 8 squared is going to be 289. When I take the square root, I get L equals 17. Okay, now 17 now is the height of each of those lateral faces, of each of those triangles that are tilted. So now to finish out finding the area of each lateral face, half of 16 is going to be 8, so it's going to be 8 times 17. So the area of one triangle ends up being 136 centimeters squared. Now, again, that's not the surface area. That's the area of one triangle. So if I wanted to find the surface area of the whole pyramid, I would have to find all 4 triangles and the base. Now, granted, all the triangles are going to be congruent, but that's what I would need to end up doing. So let's flip the page. Example number 2. It says calculate the exact surface area of the pyramid below. Okay. So in order to find the area of this pyramid, I'm going to need that hexagon that's the base. And I'm going to need to add the 6 triangles. Okay, so the hexagon, let's leave that one for a minute. And let's do the 6 triangles instead. So each triangle is going to be 1/2 base times height, and I'm going to multiply by 6 because there's 6 of them and they're all congruent. Now the base of each triangle you're going to notice is 10. The height is the slant height, which conveniently they gave us here to be 14, so we don't have to solve for it this time. Okay, 6 times 1/2 is 3. 10 multiplied by 14 is 140. 3 multiplied by 140 ends up being 420. Okay, so that's those 6 triangles. Now we have to find the hexagon. We're going to find the hexagon just like we did any other hexagon before. We're going to find one triangle and multiply by 12 because there's 12 of them. So the triangle that we are specifically looking at is this triangle right here. So this is one of the 12 triangles in the hexagon. So my one triangle is 1/2 base times height. Now the height I notice is 5√3. The base is 10, which is going to be split 5 and 5. Sorry, you probably can't read that. So I'm going to do 1/2 times 5 times 5√3, which is going to be 12.5√3. Now that's one triangle, so I'm going to multiply by 12 because there's actually 12 triangles instead of 1, which is going to end up being 150√3. So that's the area of my hexagon. So I'm going to substitute that back, 150√3. Now we're asked for exact surface area, so no decimals. I want to keep radicals, keep pi, keep fractions. 150√3 and 420, those are not like terms. So my final surface area is just 150√3 add 420 feet squared. That's it. Now I know a lot of you look at this and you don't really like this answer because it looks too long, so it might be a good idea just to switch it into a decimal also. When we do that, we get the surface area, the approximate, to be 679.81 feet squared. Okay, so that's a pyramid, and it should remind you a lot of a prism. So both a prism and a pyramid, you're going to find the faces and add them all up. It gets complicated just remembering how many faces there are, and then when you throw in difficult figures like a hexagon or an equilateral triangle. Now, the surface area of a cone is very similar to a cylinder. So the surface area of a cone is going to be the base, pi r squared, which is the circle at the bottom, and then you're going to add pi r l, l being the slant height. So just like a cylinder, a cone has a formula. You just plug right into the formula. The only thing to notice is that we use slant height and not the perpendicular height. So sometimes you're going to have to solve for that slant height. So let's jump into an example. Okay, so example 3 says, what is the surface area of the right cone? So we see that cone at the side. our surface area is going to be pi r squared add pi r L. So we're told that this is a right cone. That doesn't matter to us though. That's just extra information. Every cone has the same formula. So substituting in, I have pi times 6 squared plus pi times 6 times the slant height. Well, that's the tricky part. Here we have the perpendicular height, not the slant height. So we're going to have to solve for the slant height. The slant height is this one right here. I'm going to mark it with an L. To solve for that, we're going to have to use Pythagorean Theorem. L is going to be our hypotenuse. So we have 6 squared add 8 squared equals L squared. This ends up being 100 equals L squared. Taking the square root, L equals 10. So our slant height is 10. Now we can substitute that 10 into our formula. All the way back here on the left. Okay, so let's start simplifying. 6 squared is going to give us 36 pi. 6 times 10 is going to give us 60 pi. 36 pi add 60 pi is going to be 96 pi meters squared. So the surface area of our cone is 96 pi. Okay, so let's move on to example 4. Example 4 says calculate the lateral area of the pyramid shown. Well, this is actually a cone, so let's fix that. Calculate the lateral area of the cone shown below. Okay, so let's look at our surface area formula. So our formula is pi r squared add pi r L. That's surface area. But the question specifically asks us for lateral area. Now, this pi r squared, that's the base. So that's the circle. The pi r L, this is the lateral area. So in other words, looking at our figure, all of this part is the pi r L, not including that circle below, which would be the lateral. Area. Remember that the lateral area is the surface area, but doesn't include the base. So just the top part of the cone. Right now, I'm going to leave you and let you finish this problem. So pause the video, finish it on your own, and come back when you have an answer. Okay, let's see how we did. So I told you you're going to have to calculate pi r L. This is going to be our lateral area. So in this case, we have pi. The radius is 15. We don't know L again. So on our figure, this part right here is L. It's our slant height. As before, you had to do Pythagorean Theorem to solve for L. We have 15 squared plus 20 squared equals L squared. 625 equals L squared. You should have gotten L to be 25. So now substituting that back in, our lateral area is going to be 15 multiplied by 25 pi. So our lateral area is, this ends up being 375 pi. Now that's exactly how I want your answer in terms of pi. That's the exact answer. So hopefully you got that one right. Very similar to example number 3. If you made any small mistakes, that's okay. Let's flip the page. Okay, example number 5 says calculate the surface area of the pyramid shown. So this is a pyramid because it only has one base. That base is a pentagon, which makes it a pentagonal pyramid. So our surface area is going to be just to add up the sides, which in this case is going to be the pentagon. Add those 5 triangles. Okay, so in order to find the area of the triangle, we need the base of each triangle, which in this case is 8, the side of the pentagon, and then we need the slant height. We don't have the slant height, so we're going to have to solve for that. Before we get to that, though, let's try to do the pentagon. I'm going to help you with the pentagon, and then you're going to finish the problem. So I'm going to redraw our pentagon. All we know currently is that the sides are 8. Now, like before with the last chapter, we're going to break up this figure into triangles. 5 sides, so there's going to be 10 triangles. 8 is split 4 and 4, And then we need to solve for the height of the triangle. Now, 360 divided by 10 tells us that each central angle is 36 degrees. So it's this one up here, 36 degrees. Okay, not a special right triangle. I can't use Pythagorean Theorem, so I'm going to have to use trig to solve for that height. I do the tangent of 36 is equal to opposite, which is 4, over height, or h. I end up getting h equals 4 divided by the tangent of 36. So h is approximately 5.506. Now, one triangle of that pentagon is going to be 1/2 the base of 4, the height of 5.506, which is approximately 11.011. Okay, now our pentagon, there's 10 of those triangles, so I'm going to do 10 multiplied by 11.011, which ends up being 110.111. Okay, so that's the area of the pentagon. Now we need to find those 5 triangles. So each triangle is going to be 1/2 base times height, and then I'm going to multiply by 5 at the end because there's 5 of them. Okay, so we're not talking about the triangles in the pentagon anymore. We're talking about those lateral faces. So on our figure, I'm talking about these triangles here. There's 5 of them, they're all congruent. The base of each triangle is 8. The height is going to be the slant height. So the height that we're talking about is this height right here, which we don't have. But we do have this right triangle. We know the height is 4.8. The base of this triangle, if you will notice, is an apothem of the pentagon. The apothem we solved for. The apothem was h, the 5.506. And then we need the slant height, L. Sorry, that should be an L. So right now, you solve for L, and then finish the surface area. Good luck. Okay, let's see how we did. In order to solve for L, you should have done Pythagorean Theorem. So we have 4.8 squared add 5.506 squared equals L squared. You end up with L equals 7.305. So that then can be substituted into our formula for the height of each triangle. So then, when I do 1/2 times 8 times 7.305 times 5, I get 146.1. So that's the lateral area. That's the area of all those triangles. For the surface area, I need to add back in that pentagon, so the 110.111. When I do that, I get my surface area to be 256.211 meters squared. Okay, so that one was tricky, for sure. That one involved a lot of steps. But hopefully you were okay setting up the Pythagorean Theorem to find the slant height. If not, you now see how to approach the problem, so you can do some more practice problems in class tomorrow. Now, you have one example to do before you are done with this video. Let's return to our objectives. So we did 2 things. We calculated lateral and surface area of both pyramids and cones. Pyramids were very similar to prisms. You just find the areas of all the sides, add them up. A cone is more similar to a cylinder. There's a formula that involves both the radius and the slant height. And then we also are going to calculate missing measures. We're going to go backwards. And that's what you're about to do right now. So it says a cone has a radius of 8 and a surface area of 200 pi. Calculate the height of the cone. So my hint is, you are asked for the perpendicular height, not the slant height. Our formula, though, involves slant height, so you're going to have to find that first. I'm going to help you by setting up the problem, and then you're going to finish. So, looking at what we have a cone. that has a radius of 8. Then just thinking about cones, this is going to be the height, this is going to be the slant height, this one right here is the slant height. You are told the surface area is 200 pi. A reminder for the surface area formula, it's going to be pi r squared add pi r L. Okay, you are asked to find the height. So you want to find h, but you're going to have to find L first. So, good luck. When you come to class tomorrow, I will be checking to see that you have this problem completed. Please do not come to class and say, I had no idea. At least put forth an effort to guess and show me some work. When you come to class, we will start out by going over this problem and then the problems on the next page if you want to look at those ahead of time. Good luck.